We're going to look at a very efficient Tesla coil. A Tesla coil so efficient, it may boggle your imagination. Let's go through these points here. Our Tesla coil is only going to be powered at this demonstration by 7.3 volts from the alternator. We have the alternator running right now at 7.3 volts, upon which we will show the voltage meters of all three phases and the empty loads. Then we'll go through the Tesla coil arrangement. Number one, phase angle between two or more sources is not exclusively determined by the source, but also by the load it serves. Number two, the circle of time set at 360 degrees of separation between loads may be distorted, so the vector representations of the acting voltages must be represented in the 3D shape of a cone, rather than a 2D flat drawing. If we try to represent it as a 2D flat drawing, we get two solutions for the third vector. Meaning, in order to draw out the vector diagram, we have to prevent that from happening. And that's when we have to extend the drawing into 3 dimensions, so that there's only one solution and not two solutions. Number three, which we're going to go to straight away. The load may reflect back to its source so as to appear as a negative resistance, in which case the voltage across the load exceeds the value given to a load of zero resistance. We don't know how far that's going to take place. It's sort of iffy, but we're going to observe it nevertheless. We're going to look quickly over here. This is the 9th embodiment of the workings I've played with. This is the first embodiment using the 666 coil system as primaries. I've gone into the 666 system before. It's represented by the circling of dividing the phase into 3 segments and circling around in the arrangement shown by the colors there. You can see the beginning of phase number 2 is in the back, its next segment is in the middle, and its bottom segment, the third segment is in the bottom. Now the middle coil polarity connection is reversed. What this does is it enables that middle segment on all 3 stacks to present a repelling field to both the top and bottom segments in its stack. It has this repelling field 5/6 of the time period. It's not continually repelling, but that's the best that we can get in the arrangement, and we call this a 666 coil system because it mimics 6-phase. We have 6 polar areas in arrangement of mutual induction. That's the spaces between the different colors, whereby its actions are set at 1/6 of a cycle instead of 1/3. If it were at 1/3, we will get the opposite effect. It will be attracting 2/3 of the time period and repelling only 1/3 of the time period. Having tried to explain the 666 primary, what we do then is we place air core secondaries on top of there. This generates the voltage rise for the Tesla coil. These are 2.4 Henry, 7,000 ohm reactance coils at this frequency of 465 hertz. These are paired with 50 nanofarad high voltage capacitors, which will generate the higher voltage to ignite the arc gap down here. Okay. On the ends of these coils, the voltage secured by these coils is actually put in series to deliver the entire highest voltage to the system, and From there, we have back coil is introduced from the top, and then to the bottom goes to the arc gap, and on the other side it's introduced from the bottom and the top goes to the arc gap. This means it is strictly a bipolar coil. We can remove the ground and find that there's little effect if we remove the ground, which doesn't take place in an ordinary Tesla coil. Okay, I think we've gone over that as quickly as we can. We're going to go back to our meterings and start hooking things up. We're only at 7. We have 3 settings that we can employ. And on this employment, this is the lowest available voltage that we can derive. We have to use a solid state power supply for our field, and we have resistors ballasting that. This again is our lowest operating setting. You ought to be able to see 7.2 volts on phase 1, 7.2 on phase 2, 7.2 on phase 3. We're going to go to phase 1. Look at phase 1. We're going to connect phase 1 up. It's gone up, hovering between 7.2. We just hooked up phase 1. Its voltage basically stayed the same, but now we're pulling 0.31 amps. Those are stator lines leading to the effective amperage meter, 31 amps, 0.31 amps. Now we're going to go and hook up phase 2. Which is at 7.4 volts. Back it out of here. Where are we at here? Pardon the camera work. Okay, we found that didn't change things either. 7.5, 7.2. We now have highly unbalanced amperage, and we have current on phase 1 has gone down. Current on phase 2 is 0.7 amps. We have not engaged phase 3. Our phase rotation, from what I've determined, is actually opposite to the numbering order. We'll go ahead and hook up phase 3. Phase 3 is currently at 7.5 volts. Should be able to see that went up to 8 volts. And we have a loss finally on phase 2. That's 6.5 volts. Then on phase 1 we have 7.2 volts. So what we can see, the system is very efficient in that little or no voltage drop from the source is occurred. Go ahead and look at the coil now. Run that for a second here and see if we can perhaps manipulate the arc gap. Shouldn't be doing that. There we are, there's a good reading. From here we can see then we go all the way up to 9 volts on phase 3, 8.8, 6.6. If we took our neutral value, 7.3, well, we've lost a volt on phase 2, but we've gained a volt on phase 3. Phase 1 is 7.2, practically no change. Now we'll go ahead and look at the coil's operation itself. There's the arc gap. And here's the secondary action. Where are we at, Mary? I don't know if I can see that very well. Sunlight. Seem to be able to see something. So there you are, folks. There's a 7-volt alternator producing a Tesla coil. And so we'll call this quits for now, and we'll go over the other subjects in the next videos. Thank you.